we are going to show how to find the E field outside of a plus or minus dipole, as that like in figure 27.7 on page 822. So on page 822, we have two charges, a plus and a minus, making a dipole. So we'll draw out the dipole. And so the two charges are distance s from each other, and they have charge positive q and negative q. And so we're going to try to find the charge at point 1, which we'll put right here, which is a distance x from the origin. So now we have to remember that the E field is facing outwards of a positive charge and inwards of a negative charge. So we're going to move on to find the point, the E field at the point. And so we're going to use the equation E equals negative kq over r squared r hat. And so, first thing we're going to do is we have to find r squared. And so we know that from triangles that r squared is equal to a squared plus b squared. And so we know that r squared is equal to s over 2. So we can divide s over 2. S over 2 squared plus x squared. So we can plug this in and we get E equals negative kq over s over 2 squared plus x squared. So now we just have to break E into components, and that'll give us the x and y for the point. And so, as you can see, that the x's have the same amount of pull on each side. And so if we draw our lines with, the point coming from the charge to the point from E positive and I guess Q positive, going like this. Shoot. Sorry, that's not like that. We can see that the x components are going to cancel each other out because this one's pushing it this way and this one's pulling it this way. So we're only going to have a net y. And so we can find out the net y by using the equation E net y equals E positive sine theta plus, or minus in this case, since they're both facing down, minus E negative sine theta. And so now we need to find theta, and theta will be the inverse tangent of s over 2 over x. And so now all we have to do is we have to plug in theta into the equation, and we'll get E net y. And then to find En at 1, all you have to do is use the equation the square root of E n y squared plus E n x squared. But remember, we established that this goes to 0. Sorry. And so En at the point is equal to ENY. And that's it.